All right, so this is going to be the second video for chapter 9. Um, excuse me, section 9.2 is all about dealing with these time-related threats that we introduced you to in the first section, and also how to deal with some order effects. So this corresponds to the learning objectives 3, 4, and 5 for your chapter. And just to kind of review, that is the time delay and time related threats. And again, more about that and how we deal with that. And the advantage of switching to a between subjects design in certain scenarios, and as well as the counterbalancing technique and how that helps, and then the limitations of that, and then why sometimes partial counterbalancing is better. So, reminding you that we talked about um, previously the environmental threats to internal validity. In chapter 8, we talked about for between subjects designs, there's 3 techniques that you can use to help eliminate these environmental threats. The things like the room that they're in, or the experimenter themselves, or the time of day that you're administering the tests, things like that. And so those same 3 techniques are applicable for those environmental threats, those environmental variables in a within subjects design. So it's the randomization, the holding constant, the variables constant, and matching the variables across conditions. Those 3 things are the same techniques that you would use in a within subjects design to help eliminate those environmental variables that could become a threat to internal validity. So that is similar. What's different is the time variable, as we mentioned in the last the last video. And so controlling the time related potential confounding variables is um, the issue for within subjects design. So again, these time related threats, like history or maturation, etc., is directly related to the length of time the study lasts, right? So, um, especially, well, really all 3, history, maturation, and instrumentation, all 3 are likely going to be worse the longer the experiment takes, because the more time that there is in between testing conditions, the more time there is for those things to occur where they're growing or changing, or something in their environment changes, or something in the instrument changes, right? And so, um, ideally, you wouldn't want to go a super long time in between, because it increases the likelihood that these time related threats will be an issue. Now, that's what the second point is saying: shortening the time between the treatments, between the first measurement and the second measurement, um, that increases the likelihood, or I mean, it decreases the likelihood that there will be time related threats. However, it increases the likelihood that order effects will happen, because if you think about it, you're more likely to see practice effects and fatigue effects, um, and carryover effects if the measurements are closer together. So if it is something that they're going to be able to, quote, practice and get better at, or if it's something that's going to fatigue them, or if it's something that could carry over and affect the second treatment or the second measurement, if that is the case, the closer that they are together, the more likely those effects are going to happen, right? If they are further apart, and that's what this third statement is saying, if you increase the time between the measurements, then you are able to decrease those order effects, because the fatigue won't matter, the practice won't matter, the carryover won't matter, because they'll have faded by the time they are measured the second time. But again, if you increase the time between, then you are increasing the risk of those time related threats, the history, the maturation, and the instrumentation effects. So just like everything else that we talk about, there's give and take. There's a balance you have to find. It depends on what effects you're most concerned about. Depending on what variables you're studying, there's going to be certain effects, whether they're time related or order effects, that you're more concerned with affecting your dependent variable. And that's what it's about. So, whatever effects are more likely to impact your dependent variable, those are the ones you want to control. Those are the ones you want to adjust for. If there's things that you don't think are going to affect your dependent variable, then you don't need to worry necessarily about those. Even if the likelihood of those effects are going to increase, it shouldn't be as big of an issue if you don't believe that that's going to have an impact on your dependent variable. So again, it just depends on what your variables are and what exactly it is that you're studying. Now, another alternative is switching to that between subjects design. And so there are variables and situations where they're going to be more prone to these order effects. And in those situations, it may be better to change to that between subjects design. As we talked about in chapter 8, between subjects design is almost always an option, right? And so that may be one of those things that you need to consider. Examples of this are if there are conditions that are going to especially lead to fatigue or boredom in the participants, it may be better, instead of having them have to do it again or having to measure them multiple times, it may be better to just separate the groups into into different people. So it's not the same subjects in every group. And so they only have to do it one time. Each participant only has to do it one time. And then you are eliminating that fatigue or boredom issue. Another example is that your book talks about is the reading program. If you're implementing some different reading programs that are teaching children to read, obviously you really can't do a within subjects design for that kind of variable, because once you teach them to read, you can't erase their memories and get them back to the state where they didn't know how to read and then try the other reading program on those same students. Obviously, you can't do that. And so, in order to compare those programs, you would need to or to even to have a control condition where you didn't implement a program, you would need to have separate subjects or separate participants in each group. So it would have to be a between subjects design in that scenario. So again, it really just depends on what your variables are and what you're studying. Now, one of the things that you can do with respect to time-related variables, we talked about matching treatments for those environmental variables, or I'm sorry, matching variables across treatments. When you're talking about time, it actually has its own term. It's called counterbalancing. So, and we talked a little bit about this in the last chapter as well. But counterbalancing is basically changing the order in which the participants are experiencing the different treatments or the different manipulations or the different conditions or levels of the independent variable, so that they're each experiencing all of them, but they're experiencing them in different orders, so that you don't have to necessarily worry as much about the order effects, because they're all experiencing different orders, right? And so again, like I said, that this is matching treatment conditions with respect to time is basically what this is. And so the goal here is to make sure that you're using every possible order of treatments as possible. I said possible twice, with an equal number of participants in each sequence. So if you have, you know, 3 different conditions or levels, then you would want some participants to experience it in the order of A, B, C, and then you would want some to be CBA, you would want some to be BCA. Like, you would want to make sure that there are different orders. And we'll get into some more examples of that in a second. But again, the purpose of this is to eliminate these time-related confounding variables. The example your book used is that experiment where they talked about the putting their hands in the ice water and their ability to tolerate the pain, and the different words that they were saying. And so some participants, they split them in half so that 50% of the participants, they all did both conditions, right? They all did the swearing and the non-swearing condition, but 50% of them did the swearing condition first and then the neutral word, and then the other 50% did the neutral word and then the swearing condition. So that way they knew that it wasn't just because they did one of them first that was affecting the scores. It was that it had to be the actual difference between the two conditions, the swearing and the non-swearing, that made the difference in the dependent variable. So counterbalancing in a within subjects design is preventing those order effects from accumulating in one particular condition, right? Because the idea is if there's an order effect, it's going to be in one condition and not the other, and that's the problem, right? Because that makes it look like there's an effect on that dependent variable, but it's not coming from the independent variable. So how this works is, I kind of alluded to this a minute ago, it spreads the order effects evenly across all the different conditions. So it's allowing that fair, unbiased comparison between treatments. And we'll look at a table here in a second so that you can see how a visual example of how that works. But one point that I do want to make before we move on is that it does not eliminate the order effects. The order effects are still there. They are just balanced across the treatment conditions. So they're in both groups instead of all in one group. And that way you can still compare the means. So if that is completely confusing you, let's look at this table and hopefully this will help. So in the first two columns, this is A. This is the original scores with no treatment, no order effect. So you can see there is a difference between treatment 1 and treatment 2. The mean is 20 and 26. So there's 6 points difference between the two treatments. So assuming that's a significant difference, we can say that treatment 2 had an effect, or treatment 2 is more effective, or however you want to look at it. Depending on what those treatments actually are. Now, in the other column, the other two columns that are B, this is where they are adding the 5 to compensate for, or to demonstrate, rather, not compensate, demonstrate the order effect. So they're showing you that because 50% of the participants experienced treatment 1 first and then treatment 2, so those top 4 participants, the first 4, they experienced treatment 1 and then treatment 2. And when there was that order effect. So for treatment 2, they had to add 5 to each of those. For the last 4 participants, they did treatment 2 first and then treatment 1. And so when they did that, the order effect then showed up in treatment 1. And so there's 5, they added 5 to all of those. And as you can see from the means, they are different. So instead of 20, it's now 22.5 for treatment 1, and for treatment 2, instead of 26, it's 28.5. So the means did change because of the order effect, but the difference between the two is still 6. So again, it didn't eliminate the order effects. The order effects are still there because the means increased, but it balanced them across both treatments instead of them both being instead of them all being in one treatment condition, so that the difference between the means did not change. So you're still able to see that difference, and say that treatment 2, was significantly different from treatment 1. You're able to still see that. Now and this is good, but the potential issue or something to be aware of is that, as I mentioned, you're not eliminating the order effects. You're just balancing them. And so because of that, this can actually hide the order effects if the researcher is not aware of them. And so that can be an issue if you're not sure if was going to be order effects. You may not be able to see them this way. You may, because again, in a real research data table, there's not going to be those 5s there, right? We did that to show you the order effect, but that would not exist. The numbers would just be in that treatment one column. It would be 20, 23, 25, 19, 31, 22, 19, 21. It would just be those numbers. And your mean would just say 22.5 and 28.5. You would not know about the 20 and the 26. That wouldn't be there. The mean, the other two means from the column A, those would not be there. All you would see was column B. Without the fives, it would just be the totals and then the 22.5 and the 28.5. And so, yes, you would know you would see that there was an effect, but you would not necessarily, those means are not necessarily accurate representations of those treatments on the dependent variable, because there's an order effect involved. It increased the mean. And so you may not be able to see that if you didn't know to look for it in the first place. And so that is kind of a caveat or a warning of counterbalancing, unless you know for sure what you're looking for. There's also, well, we'll talk about that in a second, but in chapter 11, there's a way to kind of look for this situation. But there was also something else I was going to point out, and I can't remember what it was now. I might think of it in a second. It might be in the other slide. So let's go ahead and go to this slide real quick. So counterbalancing, again, does not eliminate the effects. So, oh, yeah, this is what I was going to say. So the treatments, the means are going to be affected, as we saw in that table. So if the true mean is important, in the sense that you're not just looking for a difference between the means, but you actually want to know what the value of those means are in respect to those scores, those dependent variables, because you're going to use that information for something else. If that is true of your variables, then you may not want to use counterbalancing. You may want to use a different technique, because it can distort those means. As we saw on the table, it increased the value of those means. So it made it look like the dependent variable scores were higher overall than they actually would have been if it wasn't for that order effect. And so you have to be cautious of that when using counterbalancing. Another limitation that you need to be aware of is that it's adding the order effects to some of the subjects within each treatment, but not to all. What that means is that it is creating a higher variance within the groups. So going back to this table, you see in treatment one, the first four scores were not affected, but the last four scores are now higher. And then the same with the other, with treatment two. The first four scores are now higher, and the last four scores did not change. So there's going to be a larger variance. Remember, we talked about variance. The scores are going to vary more within treatment one and within treatment two, within the groups themselves. Because of that, it makes, remember, if you're increasing the variance in between in the groups themselves, within the groups, that is going to make it harder to see the difference between the groups. So if there's more variability within those scores within each group, then the difference between the groups becomes harder to see. Remember, we talked about that in chapter 8. And so you may not be able to see the difference or reach that statistical significance that you're trying to reach between the differences between the means, if there's so much variability within your groups due to these order effects and the counterbalancing. And then also you have to be aware of asymmetrical order effects, where one treatment might produce more of an order effect than the other. So again, back to this example, we're saying that you're adding 5 for both. But what if going from treatment 1 to treatment 2 increased it by 5, but going from treatment 2 to treatment 5 increased it by 10? Right? And so instead of adding 5s in this treatment 1 column, you'd be adding 10s to the treatment 1 column. That obviously would be a problem, because then that would kind of contradict the whole point of the counterbalancing. It's not actually eliminating or balancing any of the order effects there. It's not doing what you're intending for it to do. And so um, all of this will be discussed more in chapter 11 because there are ways that you can measure for these order effects and evaluate these order effects. And we'll talk about that in chapter 11 so that you can kind of see if this is an issue in your study or something that you need to account for. So we also talked about complete counterbalancing. And so you want to have every possible sequence if possible so that you know for sure that you're balancing these order effects because certain sequences may have unique effects. So for example, having treatment 1 and then treatment 2 may have an order effect, but going from treatment 2 to treatment 3 may have a completely different effect. Or you could look at it like if you went from treatment 1, if you progressed treatment 1, treatment 2, treatment 3, that may have a certain order effect, but then when you do treatment 2, treatment 3, treatment 1, that has a different order effect, right? And so if you only looked at one or two of those combinations and not all of them, you wouldn't actually be balancing um, the order effects completely. And so in order to have that complete counterbalancing, you have to use every possible sequence, every combination of conditions. And so with two conditions, it's extremely easy, right? You literally just do like we talked about with that other study where they did 50% did treatment 1, treatment 2, and then 50% did treatment 2, treatment 1. That's the only possibilities, and then it's over, right? When you are increasing the number of conditions or the number of levels or the number of treatments, when you get past 2 and the larger number of conditions you have, it becomes more complex. Um, Specifically, it is a factorial. So, with four, if you say you had 4 conditions or 4 treatments, you would have 4 factorial number of possible sequences of those, and that's 24 different sequences. So what you would have to do is take your subjects or your participants and divide them into 24 groups, and you would have the first group experience A, B, C, D, as far as the different conditions, condition A, condition B, condition D, C, condition D. And then the next group would experience, you know, D, A, B, C. And then the next group would experience C, D, A, B, and so on. And until all 24 sequences were met. Now, that's very difficult because you may not even have 24 participants to begin with. Or if you wanted 2 participants in each sequence, then you'd have to have 48 participants. And so a lot of times the upside of the within subjects design is that you don't have to have as many participants. But when you have to start doing this complete counterbalancing, if you have several treatment conditions, then you're going to have to increase the number of participants that you are using. It gets absolutely outrageous the more you go. Your book talks about how with 6 treatments or 6 conditions, you would have to have 720 different sequences, and that's just obviously not practical. And so, in those situations, you may need to consider if counterbalancing is even the right way to go about your design, if you need to restructure your design, or you can consider what is called partial counterbalancing. And this is when each treatment condition has um, a different um, first thing. So um, it says here first in the sequence for one group occurs second for another group, and so on. But to actually give you an example of this, they use a Latin square here, which we will talk about in a second, to show how you would do these sequences. And so they have you doing, so you see A is in the first, if you're going across the rows, A is what the participants would experience first, and then B, and then C, and then D. And then the next one down, you see A has now moved to the second condition. So they would experience D first, and then A, and then B, and then C. Now, to give you an example of this, because I know a lot of these letters and stuff might just be like completely confusing. So an example would be if there were different um, memory techniques that you were using, and you were trying to compare to see which one increases memory the most. They would, you would have them, you would divide the participants into 4 groups according to like this Latin square right here. You would have them in 4 groups, and the first group would experience or would use the memory technique A, and then later would do B, and then later C, and then later D. Whatever those different memory techniques are. Um, and they would be tested each time after A, after B, after C, after D to see what their memory score was after using that specific memory technique. Another group of participants would experience that would do the memory techniques in a different order. They would do D, A, B, C. And again, that, and then the fourth, and then the third, and then the fourth groups would do the other 2. Now, some of you might be thinking, okay, hold on, this sounds like a between subjects design if we're dividing them into groups like this. But they're still all experiencing all of the conditions, right? They're still experiencing A, B, C, and D. So it's still within subjects. They're just receiving them or experiencing them in different orders, in different sequences. If this was a between subjects design, then the participants would only experience memory technique A. They would only use memory technique A, and that's it. They'd be measured one time, and then they're done. Another completely separate group of participants would do memory technique B, have their score, and then be done. They would only have one score. And then again, another group of participants would do the memory technique C, and then they would be tested, and they would have their score, and then they would be done. And then same with D. And so that would be the difference here between the 2 different designs, just to hopefully clarify things in your brain a little bit. Now, many of you looking at this little chart here may realize that there's a problem here, and that is that even though we're changing the sequence, several of them are still experiencing similar sequences, in that the first row is still experiencing A and B back to back, like A and then B, right? And then the second group is also A and then B, and then the third is also A and then B. And so if there's an order effect there, we're not counterbalancing that. We're not getting rid of that order effect. It's still going to be there, because the only group that doesn't do A followed by B is that very last bottom row. So the way to fix this in a lot of, because this is a Latin square here, is where you're taking, again, putting A first, and then second, and then third, and then fourth. But a modified version of this Latin square would be to randomly select, flip a coin, whatever you want to do, one of these columns and move it. Shift one of the columns, or multiple columns if you have to. Here, with only 4, you probably only need to shift one column, and it would be taken care of. So if we took that last column, the DCBA, and moved it over, switched it with the third column, CBAD, and switched it, if you actually took the time to look at that and do that, you would see that those conditions where there's back to back, AB, AB, or CD, CD, that would be removed because of switching those columns. And so that is one way to modify that Latin square to help further counterbalance and have more of it's closer to a complete counterbalancing than this version is. Again, so just things to be aware of with counterbalancing and time related confounding variables. this discussion activity, again, you can screenshot this if you want to try this. It's just getting you thinking about how time passing influences an outcome of something. You know, they talked about forgetting that a pizza was in the oven and it burns and then you don't have dinner. um, just considering ways that you can control these um, effects of time passing on an outcome. How can you, what are things that you can do? And again, this is to kind of get you in that mindset of thinking about these time related variables and how and why we control for them. So let's go to our learning check. And yeah, by the way, this, I want to show you this real quick, is what they were talking about with the 4 factorial 24 different sequences. So if you have 4 conditions, like what we just looked at, that Latin square, that slide we just looked at with the A, B, C, D, this would be complete counterbalancing. You would literally have 24, those are 24 different sequences of orders of those letters, right? And so using that Latin square that we talked about right here, we only have to do 4 groups here instead of 24. And so that's why that partial counterbalancing is often used instead. And that's the same chart we were just looking at. So here's your learning check. So what is the effect of increasing the time between treatment conditions in a within subjects experiment? Now, hopefully you know from looking at this that if we're increasing the time between measurements, between conditions, then we are increasing time-related issues, right? Time-related effects. So maturation, history, instrumentation, those would be increasing. So it can't be the first answer or the second answer because it says those are decreasing, and that's not what would be happening here. It would be increasing. And so it's either none or it's the second answer. And that second answer is talking about decreasing the threat of order effect fatigue. And hopefully, thinking that through, you realize that if you're increasing the time between measurements, again, you won't have to worry about fatigue. They won't be tired because you've increased the amount of time in between. So the second answer would be the correct answer. Now, your book, your ebook here has an error. It's telling you the answer is the first. And so hopefully if you already did this, that didn't completely confuse you. It actually is the second answer, that it decreases the threat of order effect fatigue. So that is an error in your ebook. I'm not sure how it is in print, but hopefully that helps clarify that for you. For the second one, for within subject study comparing 2 treatments, A and B, the researcher expects that the practice in the first treatment is going to improve their scores in the second treatment. If it's counterbalanced, then what scores will be influenced? So this is one of those things you really got to think through logistically. If it's truly counterbalanced, then it can't be the first 2 answers, because the idea is that the scores are going to be affected in both treatments, right? That's the whole purpose of balancing this, is that the scores are going to be affected in both treatments, not just one. And so it's the third answer here, the scores in treatment A for half the participants, and then the scores in B for half the participants, because they're going to be doing those in opposite orders. And so half will be affected in one and half will be affected in the other. For number 3, which of the following describes a completely counterbalanced within subjects experiment? Again, if you look through these answers, if each group is receiving a different treatment, that is a between subjects design. That's not even a within subjects design. So that first answer cannot be correct. If each participant is receiving each treatment in the same order, then it is not counterbalanced. That's the whole thing we're trying to fix, right? Is that if they're all receiving it in the same order, there's going to be order effects potentially, right? So it's not the second answer. And then the last 2 both sound possible, but hopefully you know that it is the third one a series of treatments is presented in every possible sequence. The fourth one, participants receive a random order of treatment conditions. That you could do that as a part of partial counterbalancing, but it would not be completely counterbalanced. And the question is asking what would be that complete counterbalancing. And so that would be, you'd have to use every possible sequence. So that is section 9.2. And if you guys have any questions,